Namaste. I, Jeevan Anamika Verma, Jyoti Vidyapith Women's University, Faculty of Pharmaceutical Science. Today we will talk about microencapsulation technique. What is the definition of microencapsulation? It is defined as a process of inclusion or enveloping of solids, liquids, or even gases within the second material with a continuous coating of polymeric material, yielding microscopic particles. The material enclosed or enveloped within the microcapsules are known as core materials or payload materials or nucleus, and the enclosing materials are known as spotting material or wall material, shell material, or membrane. Now, what is microparticles? Microparticles refers to the particles having the diameter range of 1 to 1000 micrometer, irrespective of the precise exterior or interior structure. Now, what are microcapsules? Microcapsules are defined as microparticles having a core surrounded by the coat or wall material distinctly different from that of the core or payload or nucleus. Now, microcapsules can be classified on three types: mononuclear, polynuclear, and matrix type. Mononuclears are containing the shell around the core. Polynuclears are having many pores enclosed within the shell. Matrix type distributed homogeneously into the shell material. Now, what are the different classifications of microcapsules? Mononuclear, polynuclear, and matrix types that we already discussed. Now, what is the reason behind for doing the microencapsulation technique? There are many reasons towards microencapsulations. In some cases, the core must be isolated from its surrounding, as in isolating vitamins from the deteriorating effects of oxygen, retarding evaporation of a volatile core, improving the handling properties of a sticky material, or isolating a reactive core from the chemical attack. Now, what are the different advantages and disadvantages of encapsulations? First, we will discuss about the advantages. First, it provides the environmental protection to the encapsulated active agents or core materials. Second one is liquid and gases can be changed into solid particles in the form of microcapsules. Third one is it modifies and delay the release of drug from the different pharmaceutical doses form that it contains, the delayed drug release form. Fourth one is formulation of sustained controlled doses forms can be done by modifying or delaying release or encapsulated active agents or core material. Now, what are the disadvantages of microencapsulations? First, it is a very expensive technique. Second one is this causes reduction in shelf life of hygroscopic agents. Third one is microencapsulation coating may not be uniform, or this can influence the release of encapsulated material. Now, what are the different compositions of coating material? First is inert polymer, second is plasticizing, third one is coloring agent. Now, what are the different methods of microencapsulation? First is air suspension. Second one is conservation phase separation. Third one is pan coating. Fourth one is FBD, that is fluidized bed technology. Fifth is spray drying and spray congealing. Sixth one is multi-oil phase centrifugation. Sixth is solvent evaporation. Seventh is polymerization. Eighth is interfacial process. Now, what are the different applications of microencapsulation? There are varieties of applications are present there. First, we'll discuss about this. Microencapsulation can be used to formulate various sustained, controlled release doses forms by modifying or delaying release of encapsulated active agents or core material. Second is microencapsulation can also be employed to formulate entry-coated dosage forms so that the drugs will be selectively absorbed in the intestine rather than the stomach. Third is gastric irritant drugs are being microencapsulated to reduce the chances of gastric irritation. Fourth is the taste of bitter drug candidate can be masked by employing microencapsulation. Fifth is through microencapsulation, liquid and gases can be changed into solid particles in the form of microcapsules. Sixth is microencapsulation can employ to aid in the addition of oily medication to tableted doses forms to overcome the problem of tacky granulations and indirect compression. Seventh is microencapsulation used to decrease the volatility. Eighth is microencapsulation provides environmental protection to the encapsulated active agents, that is from light, high heat, humidity, and the environmental factors like oxidation and hydrolysis. Ninth is the hygroscopic characteristics of many core material can be reduced by microencapsulation. Tenth is the separation of incompatible substance can be achieved by microencapsulations, for example, pharmaceutical eutectics, and can be separated by microencapsulations. 11th is microencapsulation is used to lessen the potential danger of toxic substance handling, that is the toxicity owing to handling of herbicides, insecticides, and the pesticides and the fumigants, etc., can be usefully lessened after doing the microencapsulation technique. Now we will discuss briefly about the different processes or methods involved in the microencapsulation technique. First is air suspension method. Microencapsulation by air suspension method consists of disposing of solid particulate core material in a supporting airstream and the spray coating on the air suspended particles. Within the coating chamber, particulate core material are suspended on an upward moving airstream. The chamber designed or its operating parameters influence a recirculating flow of the particles through the coating zone portion of the coating chamber, where a coating material is sprayed to its moving particles. During each pass through the coating zone, the core material receives a coat, and this cyclic process is repeated depending on the purpose of microencapsulation. The supporting airstream also serves to dry the product while it is being microencapsulated. The drying rate is directly related to the temperature of the supporting airstream used. Now, the second one is conservation phase separation. The conservation microencapsulation by conservation phase separation methods consist of three steps. First is formation of three miscible phases, that is the liquid manufacturing phase, a core material phase, and the coating material phase. Second is deposition of the liquid polymer coating on the core material. Third is the coating, usually by thermal cross-linking or desolvation techniques to form microcapsules. The deposition of liquid polymer coating around the interface formed between the core material and the liquid vehicle phase. In many cases, the physical and the chemical changes in the coating polymer solutions can be induced so that the phase separation of the polymer will occur. Droplets of concentrated polymer solution will form and coalesce to yield a two-phase liquid system. Monomers can be dissolved in liquid vehicle phase and subsequently polymerized at the interface. Important equipments necessary for microencapsulation by conservation phase separation methods are jacketed tanks with variable speed agitators. Now the third one is pan coating. For relatively large particles which are greater than 600 micrometer in size, microencapsulation can be done by pan coating, which is being widely used in pharmaceutical industry for the preparation of controlled release particulate. In this method, various spherical core materials such as nonpareils, sugar sheets are coated with a variety of polymers. In practice, the coating is applied as a solution or as an atomized spray to the desired solid core material in the coating pan. Generally, warm air is passed over the coated material as the coating are being applied in the coating pans to remove the coating solvent. In some cases, the process of final solvent is accomplished in the drying oven. Now, the fourth one is fluidized bed drag. FBD technique, that is fluidized bed drag technology methods for microencapsulation is used for encapsulation of solid core material, including liquids absorbed into porous solids. This microencapsulation method is extensively employed to encapsulate pharmaceuticals. Solid particles to be encapsulated are suspended on a jet of air and afterward solid particles are covered by spray of liquid coatings. Liquid coatings, the process of suspending, spraying, and cooling are repeated until the attainment of the desired vaporization. Now, the spray drying and the spray congealing. The spray drying and the spray congealing method of microencapsulation are almost similar that most both the methods entail the dispersion of core material in liquefied coating agent or spraying or introducing the core coating material into some environmental condition whereby relatively rapid solidification of the coating is influenced. The main difference between these two and microencapsulation methods are the means by which the coating solidification is carried out. In a spray drying method, the coating solidification is influenced by the quick evaporation of a solvent in which the coating material is dissolved. In a spray congealing method, the coating solidification is accomplished by the thermal congealing of the molten coating material or solidifying a dissolved coating by introducing the coating core material mixture into a non-solvent. Removal of non-solvent from the coated product is often done by sorption, extraction, or evaporation. Now the next one is multi-orifice centrifugation. Multi-orifice centrifugation method for microencapsulation utilizes the centrifugal force to hurl a core particle through an enveloping membrane. Various process and variables of multi-orifice centrifugation methods includes rotational speed of the cylinder, flow rate of the core and coating material, concentration, viscosity and surface tension of the core material. The multi-orifice centrifugal method is capable for microencapsulating liquids and solids of varied size ranges with diverse coating material. Now the next is solvent evaporation. Solvent evaporation method is appropriate for liquid manufacturing vehicle which is prepared by agitation of two immiscible liquids. The solvent evaporation method involves dissolving microcapsule coating in a volatile solvent which is immiscible with the liquid manufacturing vehicle phase. A core material to be microencapsulated is dissolved or dispersed in a coating polymer solution. With agitation, the core coating material is dispersed in the liquid manufacturing vehicle phase to obtain the appropriate size microcapsule. Agitation of system is continued until the solvent partition into the aqueous phase and is removed by evaporation. The process results in hardened microcapsules. Several techniques can be used to achieve the dispersion of the oil phase in the continuous phase. The most common method is used for a propeller system style blade attached to the variable motor splits. Now the last one is polymerization and interfacial cross-linking. The polymerization method of microencapsulation used to form protective microencapsule coatings. The method involves the reaction of monomeric units poisoned at the interface existing in between a core material and a continuous phase. Wherein the core material is disposed, the continuous or core material supporting phase is usually a liquid or a gas. And therefore the polymerization reaction occurs at the interface of liquid gas and solid gas or solid gas. The last one is interfacial cross-linking. In interfacial cross-linking method of microencapsulation, the small bifunctional monomer containing active hydrogen atom is replaced by a bi-sourced polymer like a protein. When the reaction is performed or at the interface of an emulsion, acid chloride reacts with the various functional groups of the protein, leading to the formation of monomer. The use of interfacial cross-linking is for pharmaceutical cosmetic preparations. Thank you.